We have all of the individual pieces of the app architecture in place. Before we can utilize them by building a UI though, we have to connect them together. Since every class is decoupled from its dependencies by accepting them through the constructor, we somehow have to pass them in. We've been doing this all the time in the tests when we mocked the classes and we pass them into the constructor, but this time we are going to pass in real production classes and not mocks using a service locator. Hello, welcome to LazySingletons, where you are getting prepared for real app development by building better, faster, more stable apps. So subscribe and hit the bell if you want to grow your coding skills. So almost every class we've created in this course up until now has some dependencies. For example, if we go and see, first close all of this, and now let's see, for example, the number trivia local data source. It has dependency on the shared preferences class. And then we also have number trivia repository, and of course that has dependencies on remote data source, local data source, and also on network info. So there's really a lot to configure even in a small app like this number trivia we are building. And there are multiple service locators which we can use for Flutter. And as you may remember from the second part, when we set up all of the dependencies of our whole app in PubSpec YAML, and we are going to be using getIt. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code from this video and overall go through this lesson at your own pace. Let's now go over all of the classes from the top of the call flow downward. So in our case, this means going from the number trivia block and ending with the external dependencies like shared preferences or maybe the HTTP package client. We're gonna set everything up in a file called injection container, which will live at the root of the lib folder. So precisely where main.dart is, we are going to create a new file. So let's right click on lib. You can also do it with command line or whatever, but let's just stick with the simplest option. This file will be called injectioncontainer.dart. And over here, the structure will be very simple. It's gonna be basically just a single top level function, which we are going to call from main.dart. That function will be called init, so it's going to initialize everything, and we are simply going to call it from the main method of our whole app. Also, we're gonna need to get the instance of getIt on which we can register individual objects, or more precisely how they are gonna be instantiated, so that when they need to be instantiated by getIt will know what to do. And for that, we obviously need to get the getIt instance. So if we import getIt, after we create void init, which we are gonna call from main.dart, now here we can technically get getIt instance like this. So getIt.instance, and for example, register something on it. But doing this is a bit long-winded, so that's why we're going to pull out this getIt.instance call and cache it inside a top level field final SL, which means service locator. And we're just going to set it equal to be getIt instance. And now we can just simply call sl.register something, so the code will be shorter. We're gonna start off with creating the first structure of this init method, because we wanna have some structure in this init method, because otherwise it's gonna become a mess. So I'm using an extension for VS Code which colors the comments. It's called Better Comments if you're interested. And whenever I put an exclamation mark before or after these two forward slashes, it's going to change the color to be red. And with that, we're going to annotate this, that the first part will be dealing with features. So here we are going to register everything regarding features of number trivia feature. So this means repositories which are a part of a feature, use cases, and also the data sources will go over here. Then the next part will be dealing with core stuff. So here we are going to register the input converter because that's a part of core, and also network info, right? That's also a part of core. And finally, we also need to tell getIt how to instantiate those external dependencies. So those are HTTP client and also shared preferences and all of that. So this will be for external. And instead of dividing this one init method with comments like this, of course, we could also create like some children init methods. So void init features, and then we would call it from within the main init method. But I think that for what we have currently, just dividing the main method of initialization with comments is plenty enough. So we do not need to create even more methods to confuse us. As you've already seen, when I was just demonstrating the getIt instance, it has the possibility to register singletons and also factories. So if we do SL, we can register factory, LazySingleton, and also just regular singleton. Let's just first deal with registering a factory, and then I'm going to explain why we register this precise class as a factory. And the first thing which we are going to register is going to be the block, because it's at the top of the call chain when we go from the UI all the way down to those external data related dependencies. So let's also provide a comment block. And now we're going to register it as a factory. So here, this register factory method takes in a function which returns t. And this is simply going to be a higher order function which will register the block by returning it. So let's return number trivia block, and let's import it, of course. So we're going to import just the number trivia block is enough. We do not need to import all of the other like events and states. And this has to take in concrete use case, input converter, and the random use case. So currently we do not have them registered. We are going to register them later, but even now we can do something like this. So SL, invoke it, we're done. What's actually happening here? Well, let's first just register all of the other. So input converter will be also SL invocation, and then the random use case will be also done through the invocation of the service locator SL. And after we format it, let's actually take a look at what's happening here. Calling SL, of course, is just a shorthand for calling sl.call, because service locator, this getIt instance, is also a callable class, much like our use cases are callable classes. And inside this call method, what happens is that the getIt instance starts looking for all of the registered types. Very much like here we are registering number trivia block, we are also going to register the concrete use case. So sl.register factory, and we would do something like get concrete number trivia and so on. And as soon as this is registered, getIt will be able to resolve the type, because it's going to infer that, oh, since concrete is of type get concrete number trivia, you probably want me to inject something which is registered under the type get concrete number trivia, right? So it's going to grab that instance, it's going to instantiate it actually for us, and it's going to pass that over to concrete. The same will happen with the input converter and with the random use case. But there is one important thing to talk about, and that's the difference between factories and singletons, because in addition to registering factories, we can also register LazySingletons or regular singletons. So factories obviously always instantiate a new instance of that given class whenever we request it. So for example, from within our first UI widget, from the number trivia page, which we are going to actually create in the next part, we are going to request that getIt gives us an instance of number trivia block. And since number trivia block is here registered as a factory, we're always going to obtain a new instance on every call to get it. However, when you register something either as a lazy singleton or as a regular singleton, trying to get that instance from getIt will always, after the first time, grant you the same instance. GetIt will cache it, and then on subsequent calls to it throughout the lifetime of the app, it's going to give out the same instance and not instantiate a new one since it's a singleton, right? And presentation logic holders such as block shouldn't be ever registered as singletons because they're very close to the UI. And for example, if the app has multiple pages between which you can navigate, you probably do not want this to be a singleton because you want to do some cleanup like closing streams and all of that from the dispose method of a widget. And as you can probably tell, trying to close a stream but having a singleton will lead to problems because you would close a stream, but if you were to come back to the previous page on which that block is being used and you would try to get an instance from getIt of this number trivia block, for example, and this was a singleton and not a factory, you would get the same instance of number trivia block as previously, which now has a closed stream because you closed it when the user navigated out of the page previously. So instead of creating a new instance with opened streams, you would get the old instance, the singleton, with closed streams. So that's why something like blocks or I don't know what else, when you have some disposal logic on your presentation logic holders, you should register them as a factory and not as a singleton. So as you already know, calling SL will do some type inference. It's going to infer that we want to have an instance of getConcreteNumberTrivia passed into that constructor parameter. So we also need to register all of these three classes: concrete, input converter, and random use case. So let's do just that, right? We're going to register use cases. This goes under the features comment because use case is still a part of the number trivia feature. And these ones can actually be singletons. That's because on them, we do not need to close any streams. And even though we are going to get always a new instance of number trivia block, its dependencies are going to get sort of recycled by being singletons. We can do that because, as I've said, we do not need to close any streams on these use cases or anything like that. And also, all of these use cases and input converter do not hold any state. So there is no point in instantiating a new instance when we can have just one of them, and it will surely be more performant. Now getIt gives us two options when it comes to singletons, because we can either register a singleton, which is a regular one, or a lazy singleton. And the only difference between the non-lazy singleton is that it is always registered immediately after the app starts, while the lazy singleton is registered only when it's requested as a dependency for some other class. So in our case, it's not going to really matter much because like immediately after we are going to request that we get an instance of the block from within the UI widget, it's immediately going to resolve all of its dependencies. And since we have really a simple dependency tree, all of the dependencies will be resolved at once because every dependency depends on all of the other dependencies below it. However, if you have multiple features, so for example, you would have a new feature settings right over here above it somewhere, and you would have settings block or settings trivia block, something like that. And the first page which you would display would be the regular number trivia page. The dependencies of settings, if they were registered as lazy singletons, would not get instantiated and resolved, and therefore they would not tax the system with some performance hiccups until the user navigated to the settings screen, to the settings page, and requested the top level dependency on that page, because only then it would kick off all of the resolving of those dependencies from that settings dependency tree. However, because we have just one tree, this really does not matter if we register it as LazySingletons or regular singletons, which get resolved immediately, but let's just stick with LazySingletons for the fun of it. So we want to register get concrete number trivia. So this is also going to need to be imported. And then of course, this also takes in another dependency, which is of the repository. So we are again going to pass in SL invocation, which will be resolved to the repository once we register it. Similarly, we also want to have get random number trivia, which of course needs to be imported and also takes in an instance of the repository. And finally, the number trivia block needs an input converter, which is actually a part of the core folder. So we're going to register it under core. So SL register LazySingleton, and we're going to just register input converter, which is actually a class that doesn't take in any additional dependencies. So that's awesome. While the dependencies of number trivia block are concrete classes like get concrete number trivia and get random number trivia, the dependency of the use cases is not a concrete class, but rather a contract, the abstract class, because our use cases, so that we do not go over the individual layers of our app, do not depend on the implementation of number trivia repository, but instead they depend on its contract, which is actually present in the domain layer right here. They depend on this, while its implementation is in the models layer right here. They do not depend on this one. So what we can do in order for the contract to be resolved to the implementation, we are going to use a generic parameter. So let's register repository. So sl.register LazySingleton again, and this time let's provide number trivia repository type over here. So let's actually copy it so that I do not need to type it out. Number trivia repository comes right here. So we're going to register singleton for that type, but whenever this is resolved, it obviously isn't going to instantiate the number trivia repository contract, because after all, it's an abstract class. It cannot be possibly instantiated. What it's going to do is that whenever it resolves number trivia repository type, it's going to instantiate its implementation. So we're going to return number trivia repository impl. Let's import that. And over there, we are going to need to pass in all of its dependencies. So local data source will be SL, then also network info will be SL, of course, and the last one, remote data source, will be also SL. And after we have that, the use case dependency of number trivia repository can be successfully resolved to its implementation. And this nicely demonstrates the usefulness of loose coupling and also why we created these contracts all along. In addition to being able to separate the domain layer and sort of, how they say, programming into the interface and not into the implementation, because our domain layer does not care how the repository is implemented. The domain layer and in turn the use cases only care that a repository provides its given methods, and how it's implemented, that's completely irrelevant to the domain layer, because a good repository has to fulfill its contract, right? You have to fulfill your contracts, because otherwise, like, you are not a good person. And sort of that's the same thing for classes. If they do not fulfill contracts, well, they're bad classes. So we can really trust ourselves in this case that the contract will be implemented properly. The same loose coupling and depending on contracts instead of implementations allowed us to actually test the class, because without it we would not be able to pass in the mocked classes, as we were doing all along in this course, but also it allows for painlessly swapping the number trivia repository's implementation for a different one without the changes to the dependent classes. So for example, we can have another implementation like implementation special, and as long as this special implementation of number trivia repository fulfills the contract of number trivia repository, we're cool. We do not need to change anything in the use cases, because they depend only on the contract. Now, of course, we need to register the data sources and network info. So those are going to be pretty simple. Again, they are programmed into the interface and not into their implementation. So we are again going to provide a generic parameter when registering that on the service locator. So data sources, those will be sl.register LazySingleton. And first, of course, let's just provide the type. So local data source, for example, or remote can go first. Let's copy that. It will instantiate its implementation. So let's just return impl, which is actually in the same file as its contract, so we do not need to import anything else. Let me actually hide the sidebar, although it's not going to help all that much. And this depends on an HTTP client, which we are going to register next in the external part, because HTTP is not our own class, it's an external package. And once we have that, we can now also register the local data source. So we're going to do just that. Number trivia local. The same goes for its implementation. And this one takes in not a client, but instead it's going to take in shared preferences. All right. And finally, the last dependency which we need to register for the repository is the network info. So this comes into the core package, and we're going to again register it as LazySingleton network info. Let's import that, and this actually has the dependency. Oh, and of course, this is an abstract class, so it has the contract also. So we need to register this network info as the contract, and its implementation is impl. And this one takes in the data connection checker. This is actually not a named parameter, so we're going to just say SL. Finally, let's go for the external dependencies, because we have now moved all the way down on the call chain, and we need to register the client of HTTP, data connection checker, and also shared preferences. Let's actually start out with shared preferences, because this one is a bit tricky. If we go as usual, SL register LazySingleton, and we would try to register it regularly, so shared preferences, and try to import that package here. We cannot just instantiate it like this because it doesn't have a default constructor. Instead, the way to get an instance of shared preferences is to call getInstance. But the problem is that this returns a future. It's an asynchronous call. So we probably need to await it, right? And for that, we need to make this whole higher order function asynchronous. So now we should be good to go, right? But the problem is that whenever you make a function asynchronous, it itself returns a future. So now we would not register a singleton for shared preferences like this, but instead it would be a singleton for future shared preferences. And actually, whenever we provide the type explicitly like this, even though it doesn't have a contract, but even classes which do not have a contract can have, of course, a type provided explicitly. Now we have an error here saying that the argument type future shared preferences returning function cannot be assigned to the parameter type shared preferences function. That's because it returns a future. So if we do something like that, we're cool. But of course, we do not want to register a future of shared preferences. We want to register just regular shared preferences. So how can we go about that? Well, we need to extract the await to get the instance outside of the registration of singleton. So this will happen something like this. We're going to just cut out this awaiting code, make this non-asynchronous, and now just create final shared preferences with lowercase s and get set it equal to be this awaited shared preferences instance. And of course, for that, we need to make this whole init function asynchronous. And now it works. So we can provide shared preferences to be registered as LazySingleton. And now these shared preferences are in fact of type shared preferences and not of type future shared preferences. All of the other singletons are going to be very simple. So let's just import up top HTTP as HTTP. And we're going to instantiate http.client here, and similarly data connection checker. So let's import that. So we've gone from the top of the call chain, from the block, which is registered as a factory, to the use cases, to the repository, to the data sources, and the same goes for the core classes and external classes. And basically everything is registered as a singleton, because no of the classes which are registered as singletons hold any state, nor do they need to close some streams once they are disposed of or anything like that. The only class which has not even a state, but it needs to have closed streams on it, is the number trivia block. So whenever you do some disposal logic, you should always register factory and not a singleton, because then you are going to get the same instance with the closed streams or closed, disposed, whatever else, and that's going to cause some problem. Now, of course, we have this init method over here, and it's not just going to get called auto-magically by itself. So as I've said in the beginning of this part, we're going to go over to main.dart, which actually still holds the main default counter app, which we are going to change in the next part, of course, with our own beautiful, sort of beautiful for my standards at least, UI. So now inside the main method, we're going to convert it to a body method, so block body. And before running the app, we are going to call the init method. So for that, let's just import. And we're going to import injection container. And let's import it as di, so that we know what we are doing. And let's just then call di.init. And now comes the question, is this enough? Well, it may seem like that, but over in the injection container, we are in fact awaiting to get shared preferences. This init method is asynchronous, but it itself does not return future, it returns void. So currently we cannot await the execution of this init method. And while I do not think that this is a huge problem, most of the time you're going to get away with it, let's just, for the sake of it, make this function return a future void. And now we can await it from the main.dart file. And of course we need to make the main function asynchronous now. We've now ensured that the UI running the app, so building the UI also, will not happen before every single dependency which needs to be registered had a chance to be registered. Again, you may get away with not awaiting when you have asynchronous calls inside the initialization function, but still, just to be on the safe side, whenever you have await inside the init, just await also the whole init method before running the app and building the UI subsequently. There have been a lot of registrations of all of those classes written in this tutorial, so to go through this at your own pace once again and to get all of the code, check out the written tutorial available from the link in the description. And dependency injection was the missing link between the production code and test code, where we sort of injected the dependencies manually with passing in the mocked classes. But now that we have implemented the service locator in the form of getIt, nothing can stop us from writing Flutter widgets, which will utilize every bit of code we've written until now by showing a fully functional UI to the user. And if you do not want to miss that part and also more tutorials like this, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best app development tutorials and resources out there. If this video helped you, give it a like and also share it with our developers who may be also struggling with the getIt package. Leave a comment if you have anything to say, any questions or suggestions. Go over the written tutorial once again if you have any doubts about what we've done here, and see you in the next video.